Bismillahirrahmanirrahim. Assalamu alaikum. Good afternoon, everyone. This is Ushna Tariq here. Living as residents over there. So I will introduce you people with my guests one by one. We are actually here with four panelists in my this panel. First of all, I will be introducing you people with Mr. Ivan Patrick Carmody. Mr. Ivan is an architect and sculptor, graduated from Southampton Institute in the field of architecture and design. He is now serving as a faculty member at University of London. He is working as a sculptor at Atlas of Design Consultant, earlier was a former JICA. Moreover, he is also practicing architecture and doing some international projects. Welcome, Mr. Ivan.
Yes.
Hello, sir. Welcome. Assalamu alaikum. How are you?
How are you? Thank you. Thank you. I'm fine. I'm here.
Okay, and now let's move towards our second guest. His name is Mr. Faratullah Qureshi. He is the Chief Executive Building Control Officer in Sindh Building Control Authority. He has done many projects in the field of planning and architecture throughout in Pakistan. I think we don't have our second guest here. We will move towards. We are moving to that third guest, whose name is Professor Dr. Architect Dr. Javairia Sheikh. She did her master's from UT Lahore. She did her PhD from Korea, and right now serving as HOD in the Institute of Punjab Multan as HOD Architecture. Ma'am Javairia. Hello, ma'am. Welcome.
No.
Ma'am, your mic is muted.
Hello, Ushna. Thank you for and thank you, Yvonne, for joining.
Thank you.
And for event and really happy ceremony was part of, and we have a coming event.
Okay, before moving forward, let me introduce you people with my last guest. Her name is architect Nida Rehman. She did her bachelor from UT Lahore, and she is working here in the field and has done many architectural projects. Right now, she is serving as lecturer at Institute of Punjab Multan. Welcome, ma'am Nida Rehman.
Thank you so much, Ushna, for the introduction. And hello to all the members participating in this session.
Thank you so much. How are you doing, ma'am?
I am good, Alhamdulillah. Hello,
Thank you so much, my all panelists, for joining over this discussion panel. I will be starting with very first question of mine with Mr. Ivan. Sir, how an artist can be a better architect, and how can we design more beautiful buildings on our region? Please tell me. How can someone be a good architect? And how can we design more beautiful buildings? So your mic is muted.
Oh, someone did mute my mic. I don't know. Is it? Can you hear me? Hello. Can you hear me now?
Yes, you're audible, sir. Please go ahead.
Okay. A good architect is actually, first of all, an artist. He has to be an artist. He can't say that he's an architect first and he doesn't know anything about art. I've always favored the idea that, in fact, every architect should learn to paint. He should learn to sculpt. He should learn, or be a very good designer. Firstly, a person who visualizes. Uh, let's put it this way: these days in Abbottabad, we have got a number of so-called architects, and they're not actually architects. They've just learned AutoCAD or 3D Max and say that they are architects. They've just got a few packages at hand, but they have no artistic talent. Have you heard of Open Office? Open Office was quite, I mean, in the 90s, it was very well talked about. Open Office. It was in the United States, somewhere, I think if it's not Chicago, it must be New York or somewhere. I'll have to go through the history of that again. Uh, they had a system where they brought in artists to design buildings. Now, if you look at my mentor, Santiago Calatrava, he's a Spanish architect and he is a sculptor and he's an architect, both. Now, when you look at his buildings, they look like sculptures, and when you look at his sculptures, they look like buildings. Now, what happens here is that we have a number of people who claim. I was with an architect only about 4 or 5 days back here in Ahmedabad, and I asked him, I said, oh, how do you go for your work and what is your strategy? He said, we don't use drawing boards, we don't use paper, we just do everything digital. And I found out that he had a number of drawings which were there and probably just AutoCADed them. And when some client came by, the drawing came to him for about 3 or 4 or maybe even 5,000, even if he charges 10,000, it's far less than what the architect charges. An architect does the work on paper. He puts all his work as, I mean, the first important thing is what is his freehand work like? What did he think when he was designing this building? If you have a AutoCAD or a 3D Max who has learned these things and he's never been to architecture college, he claims to be an architect. No, the worst thing is, if he claims to be an architect, his work is usually based on other people's designs, and he's just putting box upon box, and he's putting a facade in front and selling you a facade. It's again facadism. The main thing is that we are how we architects, I mean, architects are losing their jobs. How we architects lose our jobs just by doing the same work which the AutoCAD is already doing. I mean, he'll charge less. I may have a name, but I'll probably not get the project. There are a number of architects who've gone into, some have splayed off into real estate, becoming almost property dealers. Some have splayed off into AutoCAD designers. Now, the thing is this: if we allow too much technology into our field, we will lose our own standing in a few years to come. In fact, we have lost that standing. So, a good architect needs to bring his work onto paper first. And the stress of paper actually makes us different from what the AutoCAD is doing. I mean, AutoCAD, 3D Max, all these new packages that are coming ahead, even a lot of them are Photoshoppers, they will take another drawing and put it there and say that that's it. That's what we do. And then they're fairly cheap. So who will come to an architect when someone is doing this very cheap and doing it in the simple way? But when the result comes out, you find you walked into a box with a set of windows and an entrance called a door. The whole problem is that what he designs will not let you be in a house. You will not feel you are in a home. You will feel you got into a box, and you will feel the cold shiver of the real estate manager, what they call it, AutoCAD. You just feel that you have only paid for something to get into. But a proper house is designed in a way that you feel right, proper in it. Now, the second question that we were talking about is we are having a period of earthquakes, which will probably rise in a few, maybe days, years, or even decades to come. But this year we are having some very bad, strange phenomenon taking place, like floods. There were abundance of floods this year. I mean, especially this last month. And on the other hand, a number of earthquakes have taken place. Now the question is of making buildings. Now what they want is, most people want is just, I'm surprised when people talk about a two-marla house in which you can park a car underneath, in which you can have 3 or 4 bedrooms. I said, what are you trying to do on a two-marla land, which is just a small chunk of land? You're going to do all that? What are you wanting to kill the people, kill somebody in there, or what? I mean, it's alleged manslaughter over there. But anyway, the question is that I know Japanese architecture where you use the least bit of land for putting in the most things, but then you see a question remains. They use a lot of strong beams because Japan is a very, as far as its seismic environment is concerned, it's a very volatile area. Tado Ando is a famous architect. He's a Japanese architect. Started as a truck driver, went as a boxer. Later on, Tado Ando, the Japanese architect, he never had any professional qualifications like that as you know, a B arc, an M arc, or a something like that. He actually started at a very young age with Kabir's books, which his mother had bought him, and on that book he used to keep copying those designs, you know, probably drawing and redrawing those designs till they almost came through. The pictures almost came through. Tado Ando is one of the world's famous architects who never had a single day in a college or any institution like that, but his passion was so strong that he actually developed designs. But now we are talking about safe designs. Now it's not an issue of making a building, a set of boxes, but it's how to make it so that energy dissipation takes place in case of a heavy earthquake, let's say 8 Richter scale, or even maybe, let's never hope for a 10 Richter scale earthquake. But what we have to do is see how we can go for shapes where energy is dissipated. Well, the biggest example before us stands as a normal egg. I mean, such a shape, which is, I mean, if the egg was square, probably you'd break it from any other side. If it was any other shape, maybe a triangle, it would work. It is a peculiar kind of ellipse, a kind of elliptical and sort of a, like even a ball, but it's elliptical. And that makes certain points of it stronger than the other parts of it. A building, especially when now we're talking about snow, of course, we don't know with this global warming thing, will we see snow in the coming decade or no? But you see, I did design some buildings which were concerned with the, I mean, designs in Switzerland, and they were concerned with the, when an avalanche takes place, how will that building stand over there? Will the people inside be safe, or will it, how will it work? And that was to somehow dissipate the energy of the avalanche. On the other hand, the same design was used and reused in earthquake safe designs where we used a water tank, and we tried to shake those buildings, those models, so that we see that if they'll fall down or not. We had used very delicate sort of materials, and they were just placed one over another. They were more or less made of paper. The whole game was to see a weight on a very weak surface and how does it fare over there. So the thing is this, that now we have to work towards energy dissipation, not necessarily just looking at avalanches, but here we have to see when the land moves from underneath a building, what happens to the upper part of the building. Some even prefer to use certain kinds of natural materials underneath to keep it, for the building from sort of, you know, getting rocked. The whole thing is like, I mean, some bridges, that was the, what they call the, it was known as the leaping Gertrude, or the Tacoma, what's the name of that bridge, which fell down to the US. It was only in a very light bit of breeze that was blowing, got the bridge into oscillation. And I think it was Tacoma Straits Bridge. And that bridge came down only because of a very light breeze. The whole game is to make a building so that it can stand an earthquake. You see, the edges. The whole game is to get not let the energy of the earthquake concentrate upon its edges or points, but rather get dissipated equally throughout the building. I mean, I'll go into automobile design here. The famous smart car, which was a Swatch Mercedes art project. It has a tritium frame, which even most people do not know about, but it dissipates energy in case of a collision. It's a steel frame, and the whole smart car is made more or less of fiberglass. It's only fiberglass material. So if you notice, it's the only part that's steel is its frame, and that's called a tredian frame. Now, in a heavy collision, what happens is that this frame uh, lets the energy get dissipated all throughout the body, so that the occupants, even with the airbag deployment, are safe. So that is the same principle in buildings. They say, one of my friends used to say, he was an architect also, he used to say, if you can design a good car, you can design a good building. And if you can design a good building, you can design a good car as well. Anyway, the thing is that we have to now worry about this, that firstly, how we architects prepare our work. Are we really doing it digitally, only just digitally, or are we also looking at paper and keeping an easel? I remember my mentor also, Mr. Nida Rehman, always says that, he says, without the easel, there is nothing. Although he has several computers lying on his table when I visit his office in sometime in Lahore or Islamabad. But yet even he says that it's important that we first start our work with paper. And of course, Jan Waro Baldweg, he's a famous example of the rain house, who designed the rain house. And even the only light he ever got was from the fan light above. I mean, nothing ever came. He never even had a phone in his office. So he was completely divorced from the world. And when he was working on a design, and it was always on paper. I never saw these people talking about digitally designed buildings and all, but rather preferred paper. I mean, to start on architects' boards and paper, and then move ahead. But now we have got another challenge, and we have to keep working on designs that are safe, especially designs pertaining to earthquakes. We don't want that people should be crushed when a slight jolt comes and the building comes down. That's what our main aim should be. I hope I haven't taken too much time.
No, sir, thank you so much for explaining things in detail. For example, you talked about the usage of softwares in the construction of building material. And yes, the most important thing is that we have to finish the things in the virtual mind before, making it a physical reality. Thank you so much for your worthy words. Now I will move towards Dr. Javairia. I think she is not here in the panel discussion right now due to some internet distortions. Um, she is back right now. Hello, ma'am
Yes,
Javairia.
can you hear me?
I
Hello.
actually
Is
want to ask.
Faratullah here
Yeah,
or
you're
not?
audible.
Because
You're audible
sometimes
right now.
I can see. Sometimes I can see
Okay.
Faratullah. Is he here or not?
He is not here. Okay, ma'am Javairia, my
Okay.
very second question to you is that which kind of materials we can use to make safe and durable buildings? Ma'am, please
Yvonne
mute
has
your
already
mic.
been very kind and he has
Yeah.
spoken. Yeah, so Yvonne has already dwelt a lot on this topic that energy efficient materials are several and it is always available for us. And number two, there are a lot of different materials which we could use, which are semi energy efficient and not, and plus also some of the materials which are very as he has seen that Carlos Carpa's work, and he also spoke about the bridge which was felt because of the air wind and air gust. So yeah, it was very structural and sculptural, and unless we our material is such which is sculpturable, Yvonne will probably agree with me, and also structurable. Therefore, it will not be good to use, which is not easy to work with. So material like concrete is good and healthy, but we can also, because concrete is not one material, it is a combination of several materials. So we can always remaneuver its maneuverability so that we can make it lighter as per our demand. We can make it brighter as per our demand. We can make it more stronger as per our demand. We can make it more maneuverable and more as steel like, as wood like, or as per our wish. So it is good that its workability is in our hand, and it is very, very important for an architect to be a sculptor. Otherwise we won't be able to come up with sculptures like the one in Barcelona, and other engineering and architecture, which also includes Gaudi, because I know you are a very good fan, Yvonne. I'm just assuming that you are a fan of Gaudi because he was a structuralist. When he used to make that building, he was making it hanging upside down, and then he was putting it inverted. So yeah, like Gaudi works, like Carlos Carpa works, and like other similar architects, and especially the one who has made the bridges. So Kalatarawa, as you have already mentioned, his buildings are like sculptures, structures, and also his buildings are mobile, intelligent, and very architectural. So therefore, I wanted to say that, like Kalatarawa re-engineered the material, like Carlos Carpa re-engineered the material in that era, like Gaudi has re-engineered the material. Therefore, similarly, we have to have more greener and more healthier materials, a combination, so that we can have a better future for our upcoming generations, for our incoming years. Thank you, Ushna.
Thank you so much, Ma'am Javairia, for explaining it so aesthetically. Okay, I will be moving with my last question towards architect Nida Rehman. Ma'am, as you know, we are talking about a paradigm shifting from art to architecture.
Yes.
So I will ask you the last but not least question, that how can you relate the word art with architecture? I mean, how it has been evolved.
Okay. First, I would like to thank Dr. Javairia and Sir Ivan for such sharing such kind information. And other than this, according to your question, art is something that stimulates an individual thinking, living through the senses. And art, as Sir said, that art is like dance, moving scenes, and everything. When we are talking about the architecture, the first word that we use is art, the art and science of designing, building, and constructing buildings. So, architecture and art are basically the same. And Sir, as said, Sir, that the famous architects in modernism, they involve architectural values and artistic values in architectural buildings. If we don't do this like this, there is no difference between us and the draftsmen that are doing work in architectural offices. When we add artistic elements in our building, that differentiate our building and represent the building of an architect. Uh, some modernism, art and architecture closely relationship in modernism. Mies van der Rohe, architect, Le Corbusier, architect, and Oscar Myers, they all working by adding artistic elements and adding it as their signature mark in their architectural buildings. When we are talking about the foundation or the basic principles of art and architecture, they are basically the same, and when we linked these two elements, we construct a very impressive element that represent both the properties of architecture and art. Something that I would like to add in the end is that art need an appropriate building to showcase to the greatest effect, and architecture is that with the help of art we add artistic elements in our brick structures in by using concrete structures, that art support architecture in every perspective. This is the whole. I think Dr. Javairia and Sir Ivan will agree on this.
Thank you so much,
Thank you so much,
architect Nida
Ushna.
Rehman. So
Thank you so much.
basically, we are moving towards the ending of this session. But before moving towards the end, I would like to ask the last question to Mr. Ivan Patrick. Sir, what is your take on this thing, that how can we make earthquake-free buildings? Like, what kind of structures, what kind of materials, what kind of softwares can we implement in order to make an earthquake-free building, specifically in our zone?
Yes. Actually, as far as this is concerned, I've checked many buildings that came down during the 2005 earthquake when I was still new to architecture, quite new. Meanwhile, I had an architect who came all the way from Sialkot to check in on these buildings that fell down. Most of the structures which fell down when the edges, especially the edges of the building, failed. The edges of the building somehow or another couldn't take that shock. You see, somewhere the shock, after the shock comes to the building, I've noticed it travels to a certain point where it can get most concentrated on and tear that material. However, the materials were uniform. But another thing is that the reinforcement within the concrete and the pre-stressing is a bit of a question here. I mean, I have seen buildings where reinforcing bars have been used just as thick as my finger, and there are only 4 of them, and that building is almost 4 stories high. I mean, it is going to break like a piece of chocolate in a heavy earthquake. Firstly, I believe in one thing, that now Germans, mostly in Germany, the structures that are going on over there, we don't use, in Germany, most buildings do not prefer to use this reinforcing bar entirely as a reinforcement, but rather use beams, strong steel beams. The thing is this, that here people try to save on metal, save on money, and continue the building. And I have seen in this very place, Habibullah Colony, where I'm living in, it's near the military academy. I've seen a building right from its beginning, that they were using no reinforcing bar, and they just kept on building this house, around and around it, till ultimately someone decided that it's now no use putting any there is no reinforcement, and it never started on a reinforcement. Of course, it's still standing, it hasn't fallen down, but it's almost 3 stories high. So one thing is that we have to use the circular, up to now, we've been using the box structure. Either if we are using box structures, then we have to make sure that our reinforcements are really strong and we are using beams. Because thin reinforcing bar, this thick, thick as my finger, is not going to do you is not going to serve very much in a heavy earthquake, and you're using only 4 of these bars just to fix the edge of to reinforce the edge of a building. Now, when an earthquake comes, the energies don't stay at one place, they move. They simply move to the place where they can find a place where they can be concentrated on. And when they concentrate on that, I found was the tear, the place where the tension tore it. And the whole building lost its. There were several buildings that fell down right over here. In fact, Chen 1's part of the building had fallen down because of a mistake in the foundation. And they had this huge, heavy billboard with about 8 concrete blocks, each about maybe 4 tons. So you can see how that building went down. Chen 1 was the worst example. All the rest stayed up. The Chen 1 building, what's known as the city center here in Ahmedabad. A lot of buildings, of course, which went down were all because of poor reinforcement. The whole game is of reinforcement and pre-stressing. But I favor one thing: our buildings will have to go circular, because in circular, the energies which get during an earthquake get strong, they somehow or another cannot concentrate on one part to tear it, but they sort of merge into each other and then go back the other way. So we have done a lot of these experiments, and this will, of course, is a rather long discussion, and I think I will keep on and on with it. But the worst thing is, yeah, I can see that. But at the same time, we have to see one thing, that our buildings, all right, an architect is an artist. He's not a structural engineer. I always tell architects, please, we should remember that we are designers. We are not structural engineers, and we cannot take the responsibility of a civil engineer. I like to put a big line between the architect and the civil engineer. I always say we are the artists. We only give an idea. It's the civil engineer who has to see whether this is viable. Is it strong
Yes,
enough?
sir.
It is his responsibility to watch that. He's called a
Hello, ma'am
structural
Nida. Am I
engineer.
audible to you?
Yes, J. Ushna.
Okay, I think internet is making again distortions, technical problems. Let me know.
I think I'm all right here, and the other, you're also all right. Krishna seems to have like an internet issue there. The internet is still in its infancy in Pakistan,
Hello,
and we
Ushna.
got into. I think she's off just now.
Yes, sir. I think so.
Hello.
Yeah, it's your net keeps
Hello,
coming
am I
and going.
audible?
Although, yes, now you are. Now you are. Mhm. Oh,
So I
no,
think there is some internet connection over there.
yeah, it's in
Uh,
there over there. Although we
yes,
have
sir.
the worst internet here, but thank God today it's not so bad. We've been praying all morning.
Yes, sir. Sir, should we conclude our session?
Yes, why not? Definitely.
Uh, yes, sir. Sir, thank you so much for sharing information. And
Welcome.
in the last, like you said about the difference between the architects and the civil engineer, that we all should know that there is a whole difference between civil engineers and the architects. We can't do their job responsibilities.
Exactly.
Yes, sir. Sir, thank you so much for your time, and thank you so
Welcome.
much for sharing such kind information. We will have another session, inshallah, soon with you.
I'll be waiting. I will
Yes,
be
sir.
looking forward to it as well.
Yes, sir. Thank
Okay.
you so much, sir.
Thank you so much. Thank you. And have a nice day. Thank you.
Thank you. Yes, sir. Thank you. Sir, I think we should have to leave the studio. There is
Yeah,
some
we'll have to leave it.
internet. Yes, sir.
How
So
do we
there is
leave?
some
I think
button
there's
over
a.
the.
I
So there is
presume
some
there's a
button over
red
leave
mark
the.
over it.
Yes, sir. Yes.
I don't know
Goodbye,
if
sir.
it'll work. Okay, bye. Have a nice day. Have a nice day.
Sir, thank you, sir.
I'll